Okay, so what's happening over here is measure of dispersion. The range is the difference between the largest value and the smallest value. Correct? The simplest measure of dispersion. Dispersion means the spread of the data. How data the spread is. How spread the data is. The other method, so this is one way of doing it. One way of you find a range. Well, how do you find range? Highest minus lowest.
Yeah.
Second method of finding the dispersion is finding the quartiles. Lower quartile is 1/4 of the data lies below the lower quartile.
Yeah.
And 3/4 of the data lies above it. And it's also called the 25th percentile. So you do n plus 1 over 4. N plus 1 over 4 value if it's discrete.
Okay.
For median, what do you do? N plus 1 over 2 value. That's used to find a median. And how do you find the upper quartile?
What is n?
N is the number of terms.
Okay.
And n is the number of terms. So, example, if you have 7 terms, 1, 2, 3, 4, 5, 6, 7. What will your median be? How you arrange in ascending order? What will your median be?
N plus 1 over 2, 7 plus 1 over 2. So
fourth value. So basically, what are you doing? Your fourth value 1, 2, 3, 4. Okay. Now, what will your lower quartile be?
N plus 1, so 7 plus 1, 8 over 4, so 2.
Second value. So basically, the lower ka, whatever, the median of the lower part is your lower quartile. Basically, the middle of that. The middle of the entire thing is median.
Understood.
Then this ka median is lower quartile. This ka is the upper quartile. But you have to do n plus 1 over 4. Some textbook make a mistake. So interquartile, whether n is odd or even, it doesn't matter.
Okay.
IQR interquartile range is Q3 minus Q1. Q3 minus Q1 is your interquartile range. You can get a sense of the data sets distribution by examining the 5 statistical summary. This is called a box and whisker plot, where you have the lowest, the lower quartile, the median, the upper quartile, and your maximum. Your range is highest minus lowest. Correct? And your interquartile range is the difference between Q3 minus Q1. Outlier. Outlier extremely high values or extremely low values which may not be part of the data set. Which are not part of the data set. And outlier is any value which is 1.5 times IQR above Q1 or below Q. So basically the upper boundary you can say Q3 plus 1.5 times IQR. So if any value lies above this, it is called a outlier.
Outlier, okay. So but that's like
low boundary. Yeah, low boundary will be Q1 minus 1.5 times IQR. Q1 minus 1.5 times IQR.
Okay.
So these formulas you have to remember. This is not in your formula booklet. This is not in your formula booklet. So make it a point that you learn this.
Okay.
The range and the interquartile range are the easiest way to calculate and measure the measure of the spread, but is not sufficient as each one is calculated only from 2 data values. So therefore we have to use variance and standard deviation, which is widely used.
Okay.
Now what is variance? Now variance is the arithmetic mean. Now this formula you have to do everything on calculator. You don't have to do by hand.
Yeah.
So what you have to do is you have to take the difference between each value. You take each value. You take the difference of that value from the mean. You square it. You take the sigma of it and you take the average of it.
And how do I put this in the calculator?
No, you have to put a data in the calculator. It gives you the standard deviation directly over there. You don't have to do it.
Standard deviation will give me what? Oh, is variance the same as standard deviation?
Standard deviation is square root of variance. Standard deviation is simply square root of variance.
Should I write this formula down?
Not required. It's in your formula booklet, but it's not required. Because you have to do everything using calculator. So standard deviation sigma is the square root of variance and has the same units as the data and shows how much variation is there from the mean. Like if you have two bell-shaped curve, this one is thinner, this one is thicker.
So high standard deviation
Will
means
be
that there's
will be
typically
more broad, more
yeah,
spread.
so there's typically like a bigger difference
Bigger,
between
big,
each,
bigger,
like a bigger
yeah.
deviation.
Bigger deviation
between
from the
each
mean.
Yeah, and lower standard deviation
The
means
smaller
all your
deviation from the
numbers are also probably closer
yeah,
to the
closer
mean.
to the mean.
So like for example, if I have a 2, 3, 4, 5, that could be low versus if I have 2, 8, 12, 24, that
Perfect,
would be high.
perfect.
Okay.
Excellent. But that's a measure of it basically. That's how we calculate it. Properties of standard deviation.
You show us this thing.
Yeah.
In class, like something about statistics. She's showing us this stat about how the biggest political party in Austria put this ranking. It was like a bar chart ranking of first, second, third, fourth, like that. But there was no 1, 2, 3, 4. And these guys made it seem like Austria was third. Turns out it was a real statistic. They just cropped out the top.
Yeah.
They just cropped out the top so they would look higher.
Yeah. Properties of standard deviation. Sigma, this symbol is called sigma. Standard deviation is only used to measure spread or dispersion around the mean data set. Standard deviation is never negative because you're taking root and you're taking only the positive root. Standard deviation is sensitive to outliers. A single outlier can significantly increase it, distort the representation of spread. For the data with the same mean, the greater the spread, the greater the standard deviation. Spread is the width of the data points. Correct? This is the spread. So the orange one is having more spread. If all the values of the data set are the same, the standard deviation is 0. There's no spread of the data points. Like a child who consistently gets a 7 in maths, standard deviation is 0.
But occasionally sometimes we get
then you get some standard deviation. You contribute to some standard deviation.
Unfortunately or unfortunately.
Assume that x bar is the mean and sigma is the standard deviation of a data set. What happens if x bar and sigma, if each number is increased or decreased by a constant?
Okay. So if all numbers let's say we have something, all numbers have increased, then the mean would increase, but the standard, do we assume that they've all increased the exact same?
Yes.
Standard deviation decrease. Remains the
Increases
same.
or decreases, by the same value.
Yeah, and standard deviation doesn't change.
But the spread does not change.
Yeah. And in the other one, it's the opposite.
Multiply or divide by a constant.
Yeah, it's the opposite because your standard deviation will stay the same because your ratios are remaining the same even though the individual values are different. Change.
So the new mean
is gonna be whatever.
C times the old mean.
Yeah.
And your standard deviation will also be C times the old standard deviation. So please remember that.
Cool.
Find the range, median, low quartile, upper quartile, and interquartile range for this set of data. Chalo, do this.
All sum in like 2 seconds.
Yeah.